Good morning. Just had your class, right?
Yes.
You can like go to washroom if you want to right now. Do you want to go to like washroom? Just like a break. Because I just saw you guys having your class right now. Let's wait for your friends. Your friends are not coming. Good morning, Poon. Good morning, Baikaw. Good morning. I will check your attendance, okay? Baikaw, what is your name? Not your name. Your real. Number 8? No, 8 is Hakura, right?
7.
7? And Poon, what is your name? Real name?
Poon Lisa, number 3.
Number 3? Okay.
Yes.
Okay. It's already 11:03. Okay, I'm gonna put them absent now. Have to be strict now. Okay. Okay, so it's only 3 of you. So I might ask you guys question again and again. Okay, let me try to share my screen. So today we will be starting with new chapter, okay, which is chapter 3. It's about mixture. Chapter 3, mixture. So we have a lot of writing today. It's going to take a lot of time. Page number 27. It's chapter 3. It's about mixture. And we're going to do exercise, which is on page 28, 3.1. Exercise 3.1, separating mixtures. So this topic is going to be a little bit tough. So you have to listen carefully, okay? I'm going to share my screen now. Let's start our class. Let's not waste time, okay? Okay. Chapter 3, mixture. So the word mixture here means, what do you understand by the word mixture here? What do you understand by the word mixture here? Something that is mixed together, right? Something that is mixed together is called as mixture, right? So, okay, let's go to this one. Let me give you more detail here. Mixture is made up of two or more than two components that are physically either by stirring, shaking, or dissolving is called as mixture. Okay, we can mix things by stirring, okay, by stirring the objects, stirring the liquid, right? Or we can mix it by shaking, or we can mix it by dissolving the objects, okay? So mixture is made up of, it can be made out of two, more than two objects, okay? Let's say water and salt together. We can mix it by stirring, right? We can mix it by stirring, right? And also we can mix things by shaking the beaker, okay? And also we can mix it by dissolving, okay? Dissolving on its own, right? The medicine, this one is a medicine, right? Medicine dissolving in the water. So these are the three different types, okay, of mixing the mixture. Let's go to second one, next one. A mixture is a combination of two or more substances that are not chemically combined. For example here, what is this? It's a mixed. Is it fruit? What is it? Spoon, what is this? We eat this, right? It's very healthy for our body. What do we call this? The word starts from S. Yes?
Salad.
Yes, very good. It's a salad. And salad here, it's a mixture of raw vegetables, right? So this is also a mixture. Okay, so here, there is combination of not only two, there is more, right? There is tomatoes. I can see so many things here, okay? The coriander, right? And other vegetables as well. I don't know what vegetables, but there are a lot of things mixed here, right? In a bowl. So this is called as mixture, okay? Mixing everything together, okay? It's called as mixture. Salad is one of the examples. So other examples of mixtures are sugar solution is one of the example. Water, salt water is another example of mixture. Smoke, as the example of mixture. And marbles in the water is the another example of mixtures. All right. So in order to separate this mixture, okay, we have so many methods, okay, but we will learn 6 of them later on. So in order to separate those mixture, we have so many methods. So we're gonna look at those methods one by one later on, okay? So separating mixture means a separation, okay? It's a process of separating or transforming the mixture of substances into 2 or more distinct materials. So here, what happened here is, when we separate, what happens? Let me give you an example. The water and the, what is this? Water and a sugar, let's say, water and a salt, right? So when we separate those 2, we have those methods, okay? We use those methods and we try to separate salt and water differently, okay? So this one is called as separating mixture, okay? So mixtures can be physically separated by using methods that use difference in physical properties to separate the components of mixture. So we're going to look at those methods, okay? So we have around 6 of them. There are a lot of methods to separate the mixtures, but we're going to be looking at only 6 of them. The first one is called as, what is it by cow? What do we call, how do you pronounce this?
Evaporation.
Okay, evaporation. First one is called as evaporation. Second one, Hakura.
Crystallization.
Okay, very good, Hakura. Crystallization, right? And third one, Poon.
Simple distillation.
Yes, simple distillation. And fourth one is called as vapor chromatography, okay? And fifth method is called as solvent extraction. And the last one is called as steam distillation, okay? So these are the 6 different kinds of methods to separate the mixture, okay? So before we jump onto the method, let's look at some of the words that you need to know before we move on to the process of separating, okay? So the first one is called as solute, okay? Solute. The substances that is being dissolved is called as solute, okay? You can write this down as a note, okay, in your book, because I can see in your book that there's nothing there, right? I can see only questions. A solute, the substances that is being dissolved is called as solute. Remember this, okay? Because later on you will get confused, solute, solvent, and then there's like solution. It's going to be very confusing. So you have to remember this first before we start the process. Okay, let's look at second one. It's called as solvent, okay? First one is solute, second one is solvent. Solvents are the substances that are used to dissolve the solute used in formulation. So for example, in order for you to understand it more, I got a picture for you guys. So here, in a sugar water solution, sugar will be the solute, okay? Sugar will be the solute, whereas the water will be the solvent here. This is a sugar, right? This is a sugar cube. Sugar cube will be the solute here, okay? Something that can dissolve is known as solute. Whereas this one is called, the water is called as solvent. It allows things to dissolve, right? So these are the 2 differences. Solute is the ice cube. Solid is the sugar cube and water is the solvent, okay? This to remember that. And when we mix this together, we get a solution, okay? So let's look at solution next one. Okay, solution is a mixture of consisting of solute and solvent. This one is a solute and this one is a solvent. So when we mix these 2 together, we get solution. So we call this solution. Okay, you can take a note because later on you might get confused. See, in a sugar water solution, sugar is the solid and water is the solvent. Whereas when we mix these two together, right, we get a solution. Oh, PP just joined in. PP. Before I end the class, I will again take attendance, okay? So PP, I didn't take your attendance, right? So please let me know, okay? Right before we end the class. So that I could mark you as present. Okay, did you take a note of this? Okay, now let's move on to next one. Okay, it's a homogeneous mixture. So the homogeneous mixture is a mixture in which the composition is uniform throughout the mixture. For example, water, air are the example of homogeneous mixture. So homogeneous mixture will be something like this. Something that can mix together is called as homogeneous mixture. Understand? So to put it in a very easy word, homogeneous mixture means something that can be mixed together. Water and salt can mix together, right? But some of the objects, they cannot mix together. I will give you an example later on, okay? So homogeneous mixture are like that. Something that can be mixed together, okay? So the example can be water and air. All right? Homogeneous mixture. Okay, now let's look on to the next one. It's called as immensible solvent. Okay, immensible solvent is of a liquid not forming homogeneous mixture when added together. Okay, so here, what happens here? Immensible is something that cannot mix together. Okay, for example, oil and water. When we put oil and water, do you think it gets mixed together? It doesn't, right? It stays something like this. You can see, right? The water, when we pour water and oil together, this is how it's going to stay inside the glass. The water will be in the bottom, and whereas the oil will be on the surface, right? So these two doesn't get mixed together. So this is the example of immensible solvent. Okay, immensible solvent of a liquid. Okay, it's only liquid that doesn't get mixed together. Homogeneous mixture is something that can mix together. It has solid, also liquid also, okay? The gas also for the homogeneous mixture. But for the immensible solvent is only about liquid. All right, everyone? Understood? Okay. Now, let's move on to the next one. The 6 different types of separation methods. Now we're going to look at 6 different types of separation methods. So in your book, it's a little hard, so I try to make easy for you guys here on the screen. So you can maybe take some notes from my screen. Who knows, it might come in exam, right? So it's better you take note beforehand. Okay, the first one, let's look at the first one. It's this this method is called as evaporation. Okay, the first method of separating mixture is called as evaporation. Okay, to separate, the method for evaporation is to separate a dissolved solid in a solvent. Okay, the method here is to separate a dissolved solid in a solvent. Okay, so here what we do in this process is the mixture is heated. Okay, the mixture, right? These are mixture, these two mixed together, right? It's a salt and water. They are mixed together at first, right? So in order to separate those two, what we do is we need to heat. Okay, we need to heat the mixture. A mixture is heated slowly to evaporate off the liquid and leaving behind the solid. So When we heat it, what happens? The liquid, right? The solvent or the liquid will evaporate. And when it evaporates, what happens? The solute, the salt, right? It will left behind. So this is how the evaporation process works, okay? Process or the method works, okay? So this is how we separate. All the solute will left behind, whereas the water will all evaporate. Okay? This is the first process. Now, let's look at the second one. It's called as crystallization. Okay. So this method is to obtain the pure solid from an impure solid. Okay? Pure solid from impure solid. For example, first, let's look at the first solution here. First example here. Okay, first diagram here. So here, the impure solid is dissolved in a solvent. Here, it's mixed together, right? It has been dissolved in the first place, right? And in order to separate those two, what do we need? We need to heat. Okay, the solution is heated to evaporate most of the solvent here. All right, everyone. So impure solid is like this. There is like pure solid and impure solid, right? Impure solid is like materials, okay? That is not pure, it's called as impure solid. For example, salt mixed with water is impure solid, okay? Pure solid example can be diamonds is a pure solid. The gold is a pure solid, right? So impure solid can be mixture of two different things. Pure solid will be only one. Understand? So to separate those two, we use the process called crystallization. Process or the method called crystallization. So this crystallization will obtain the pure solid. They will take the pure solid from the impure solid. So in order to do that, we need to heat the water here. Okay. The solution is heated to evaporate most of the solvent. Same like the process one, right? It's almost same like the process one in evaporation, right? So here also, we heat the solution and let the solvent, right? Let the solvent evaporate. And later on, what happens is the hot solution is allowed to cool and the solid appear as a pure crystal. So here, after heating it, okay, after heating it on high temperature, the pure crystals, right, the solid, pure solid will remain on the bottom here, okay, and this one, the solvent will remain here, okay, after heating it. And after heating it, we pour it, okay, we pour it onto the paper, okay. Okay, this one is called as filter paper. We pour it on filter paper, and on the filter paper, when you pour it, all the pure solid will remain on the filter paper and rest of the liquid will drain away, okay? Understand, everyone? The cold solution is poured off to obtain the crystal. The crystal here is the pure solid, okay? And the crystals may be dry by pressing them between the sheets of filter paper. Later on, what we can do is we can press, okay, we can press the sheets of the filter paper and you can get the you can get the pure solid here, okay. Crystallization is the pure solid here. Do you understand? Are you getting confused? No? Okay. It would be nice if we could do experiments together, right? Like in the class. Okay. See here, last one. A hot mixture is cooled and pure crystal will appear. Okay, after being cooled down for some time, the pure crystal will appear on the sheet of paper, filter paper. Number 3 is called as simple distillation. Okay, distillation is all about like evaporation and things like that. Okay, so we're gonna look at this one. It's very easy. Third process is called as simple distillation. So simple distillation, right? The process here is to separate, okay? The method here is to separate the liquid from the mixtures of different boiling points, okay? So in order to do that, the mixture is heated. So here is the mixture here, okay? This is a mixture here. The mixture is being heated here. After being heated, the liquid with the lower boiling point, okay? After being heated, right, the liquid with the lower boiling point evaporates, okay, evaporates. The steam goes out from here, okay, steams evaporate and later condense. Do you know the word what condense means? Condense. Do you know, Hakura, do you know what condense means or condensation meaning? No? Okay, so condensation is something like this. Okay, let's say, for example, I boil a water. Okay, so the water, when I boil on high temperature, what happens? You can see the steams coming out from the water, right? So that one is called as evaporation. And when we collect those steams, okay, it becomes water. So we call it a condensation here. Gas becoming liquid. Gas changing to liquid is called as condensation. All right? Okay, so this one is a condenser, the tube. Can you see this long tube? This is a condenser and you will collect the water here, the steams from the steams. So this is the process here. It's very easy. Okay? So a liquid with a lower boiling point will evaporate, right? And it will, okay, let me draw it. When we heat the water, what happens? It evaporates, right? The liquid evaporates, right? So it evaporates and goes here, 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 and then later it comes here, okay? And it's being condensed, right? And the liquid, you will get the liquid droplets and the water is collected here in the jar, right? In a beaker. This is how it works, okay? Simple distillation. It's very easy. Okay, now this one we can do it by ourselves also at home. Simple distillation. Okay, now let's go to next one, the fourth one. This one is a little bit tricky, okay, everyone? Number 4 is called as paper chromatography. Okay, paper chromatography. So here, the process here is, the method here is to separate the color components, okay? Different color components. Different colors, okay, are being separated from each other, okay? So here, the simple chromatography is carried out on paper, okay? In order to do this method, we need paper, okay? It's carried out on a paper. Okay, let's look at this one and I will explain you later, okay? So the component in a liquid mixture moves up. This is the process, okay? The component in the liquid mixture, right? The component in the liquid mixture moves up the chromatography paper with the solvent with different speed. With different speed and separate on the paper. So this one will, water is it solid or solvent? Baikau, is water a solid or solvent?
Solvent.
Yes, water here is a solvent. Okay, so the component in the liquid mixture, right? The solvent here, right? We need to put this paper, need to dip this paper inside the liquid. Okay, I'm gonna explain you here in more detail. So here, what happens is the spot of the mixture is placed near the bottom of the piece of chromatography paper. So we put this paper, okay? We put this paper into the water, okay? In the solvent, right? And then the paper, what happens is we put it upright in a suitable solvent such as water. We put it into a water in upright direction, okay, position. And later, as the water, when it soaks up the paper, right, it carries the mixture with it. Can you see this? These ones are the mixture. So it's being separated here, right? The mixtures, right? These are the mixtures. So when it soaks up, it will carry the mixtures on paper like this. All right? All right, so this is the process here. Do you understand this one? Is it a little confusing? Understand? Okay. So in this here, right? I will explain you again, okay? In this process, what happens is we put a piece of paper inside the solvent, okay? We put a piece of paper in the solvent. And what happens after being soaked up, okay? After the paper is soaked up, it will carry out the mixtures outside like this, okay? This is how it separates from each other, okay? All right, let's go to next one now. Number 5, the solvent extraction is to separate liquid from the mixture using a solvent due to its solubility in the solvent, okay? Both the mixtures and solvent are immensible. Do you remember the word immensible? Do you remember the word immensible? What did you write down? Baikal. I think Baikal write it down, right? Already. What is immensible?
Something that can be mixed.
Yes, something that cannot be mixed together is called as immensible, right? Very good, Baikal. Something that cannot be mixed together is called as immensible. Okay. So here, both the mixture and the solvent here, right, inside this one is immensible. Okay, so it's very easy to separate those two things. Okay. So you can see that here in this picture that the solvent, right? Both solvent and solid, they didn't get mixed together, right? You can see it clearly here on inside the beaker. It didn't get mixed together, right? Because both of them are immensible, okay? So this is done by using two liquids that doesn't mix. For example, water and organic solvent. Okay, organic solvent can be like alcohol, like carbon base, okay, which is capable of dissolving. Okay, this is very easy. The process, you just put it in separate. Okay, let's move on to the last one, which is called as steam distillation. Okay. Steam distillation, the method is to separate temperature-sensitive liquid from a mixture of a different boiling point, okay? This is almost same like this one, right? The simple distillation, almost same like simple distillation. So steam distillation is, you know the word steam, right? Right? Okay, so here the method here is to separate temperature sensitive liquid from the mixture of a different boiling point. Okay, so the temperature sensitive meaning here is something that is very sensitive to liquid, that is very sensitive to heat is called as temperature sensitive, okay? For example, let's say foam, okay, foam, the soap, right? They are temperature sensitive, right? Okay, let me explain you in detail here. So instead of using direct heat, okay, we use simple distillation. The steam is used here, okay? So the mixture is heated until one of the components boils and turns into a vapor, okay? So here, sorry. So here the process is like this. It's heated, okay? One side of it is heated, and what happens is one component boils and until it turns into vapor. This is how it separates, okay? The mixture is heated until one of the components boils and turns into a vapor. When it turns into vapor, this is how it separates, okay? So it goes like this. The vapor, right? It goes from here into here. And then the vapor will be going back to here. And this is the receiver here. So this is how we separate from one another. Okay, only the steam, we use only steam. These are steams, okay? These two are steams. Only the one side is boiling, right? Liquid, there is liquid here. But these two are steams. We use only steam here, okay? Whereas in the simple distillation, right? We use evaporation. We use liquid and steam both, right? But here we don't use, okay? So this is the process here. Only the vapor. We use only vapor. So with this, we are done with 6 different kinds of methods for separating the mixtures. Okay. Let's see how many minutes we have. Okay, we only have 5 minutes. So the question here, question 3.1, we will do this exercise, page number 28. So the first one, describe the following separation method briefly, okay? So here, the method is very lengthy, right? So I wrote it in another sheet, okay? In another PPT, in another slide. So first one and second one, I wrote it here, okay? So a mixture is heated slowly to evaporate off the liquid and leaving behind the solid. It's called as the one process, first one, evaporation. So you can write this down. Done, first one. Okay, let's move on to next one. Crystallization. A hot concentrated mixture is cooled to form a crystal. Done? Okay, let's move on to number 3, simple distillation, okay? So I wrote it here, it's very lengthy. We have only 1 minute. So maybe you can take a picture of it and later you can write it down. It's a lot, right? So you can write it down. The process itself is very lengthy, that's why. You can take picture. Have your phone, right? Take a picture. So with this, we are done with our class. And I will see you guys next week. And have a nice weekend, everyone. Take care. Have a nice weekend. Bye-bye. Pipi. Sorry, Pipi, what is your real name? Hello, Pipi. Hakura, do you know Pipi's real name? Oops.